Hello, welcome to Advanced Algebra 2. Here we have a quick set of notes, and I believe our last set of notes for the sixth learning target, which is actually sort of our third learning target. Don't worry about that. So, here we've got a situation where I've got a system of equations, so we're back to equal signs, but they're not both linear. So, one of them's quadratic, and we should have some good experience with quadratics, and then one of them is linear. So, we're going to graph them because it says make a careful graph. So let's get started. Now, I'm going to call that first, the top thing, equation 1, just to have something to label and to work with. And so if we're going to rewrite it, we'll go ahead and factor out the negative sign. You can see, and I hope anticipate, I'm going to complete the square. That's a quadratic, and so, vertex is probably the most important thing to get down. So you factor out the negative sign, which means it's plus 6x now, so you really need another 9 in there. So you need to take that away on the outside. But remember, you had factored out the negative sign, so you're taking away negative 1 times 9. Still with that minus 7 hanging out, saying, what about me? Etc. So then, now, if you take out that negative sign, you got x plus 3 squared, and then plus 2, because it's really like a plus 9 minus 7, so it's plus 2. Okay, now, what this means, just quick reminders, the vertex is going to be at negative 3, comma 2, and that shouldn't be too hard because the graph has moved left 3 and up 2. This is also going to be upside down, and that's because the negative number in front, I mean, you should know negative x squared's, going to be a hill, not a valley, for a parabola. And then this last thing I haven't talked about yet, it's possible, of course, that you did in your Algebra 1 experience, and it's worth looking at just super briefly. It has a thing, kind of like a steepness quotient, like a steepness measurement. It's like slope for lines, except that, well, parabolas aren't lines. So I call the parabola steep scale, and it's got 1, and that's because the number in front of x squared is 1. Now, well, actually, in this case, it's negative 1, but the value of, like, how big it is, or rather, its absolute value is 1. So what that means is this. The vertex is negative 3, 2, and it's upside down, so we're going to head downstairs, not upstairs. Now, that means, then, that... hold on a second, I got too excited there. That you go down 1, let me say this again. From the vertex, as you move left and right 1, you go down 1 to get to your next spot. And there's 1 on each side because of the symmetry. Then, as you go left and right another 1, you go down 3 to get to your next spot. Again, each side because of symmetry. And then your next spot over left and right 1 makes you go down 5 to get to your next spot. Again, with the symmetry. So you can see the 1, the 3, the 5, they're just increasing odd numbers. So the next dot over on that parabola would be 7 down, and the next one would be 9 down. And again, you might very well know this. It's not a top secret issue with parabolas, but it's not like the high-level thinking I demanded in the last unit because I was drastically more interested in intercepts. Anyway, here I want nice lattice points, that's nice integer coordinate points on my parabola, so I did these dots this way, but now I'm going to make those go away because it's going to get in the way. Alright, now, oh, I drew them again. I was so in love with them. Okay, now they're going to make the parabola graph. Boom. Chicka-boom. Okay, now I really do need these to go away, so I'm going to go ahead and erase my numbers. The parabola, of course, I need to stay. It's not doing any harm. In fact, it's doing a lot of good for me. But those 1, 3, 5 business. Okay. I think I made the little corner points. They're not corners, I know. Little lattice points bigger here, just to help us notice what's going on. Now, the other equation is a line. I mean, come on, it's a line, right? So you subtract the x, so y equals negative x minus 3. So just, a quick reminder of life. The slope is negative 1. And then the y-intercept is 0, negative 3. You want to say it's negative 3, but it's a point. Maybe that's just me. Who knows? Anyway, so yeah, put the slope down, or the y-intercept down, and from there you do the slope, and then you dot it. Again, please forgive me, my lack of straight edge. I'm doing my best on an iPad screen. It's a little challenging. So you're looking for where they cross, and that's not really hard to notice, to be honest. You're like, there and there. And unfortunately in math class, the word there is not actually an answer to a test question. So we need the actual points where they cross. Talking about -4, 1, because over on the left of the circled points, and -1, -2, which is the right circled point. That's it. So nothing terribly hard. You graphed a parabola. A little trick on how to put more dots down without making a huge table. If you didn't understand it, I'll try to show it again in class. If it still doesn't take, you always can make a table. It's not a disaster. And then with a line, slope, intercept, life is good. Okay, that's it. Now, except second example. So second example is this, and you're like, wait, that's the same thing. It totally is, except the directions are different. We have to solve it symbolically. So first order of business, take that line and solve it for y. So y equals -x minus 3. Subtracting the x on both sides. Now, they both start with y equals. So what we're going to do is called substitution. And I guarantee you did substitution in Algebra 1, although it was probably just lines and lines. But now we're going to do substitution with apparently a parabola in a line. And so since they're both equal to y, that means the stuff on the right side of the equal signs are both equal to each other. So the parabola business, -x squared minus 6x minus 7, equals the line business, -x minus 3. Well, now we'll just move it all over. So move the x squared over, move the 6x over, move the 7 over, and now it's 0, so you can factor. If you're having a bad day, you could use the quadratic formula, but it's x squared plus 5x plus 4. It's, of all the things in the world demanding to be factored, this would be high on the list. It's x plus 1 times x plus 4. So the first value for x is -1. The second value for x is -4. Again, if for some reason this just blows your mind, well, we have a long-term problem if this one blows your mind, to be honest. But, for now, you could use the quadratic formula. All right, so you're not done really, though. You need y values. So I would recommend plugging them into the line. You could use the parabola on top instead. And if you want to be safe, you can do both. So, you take -1, which is the first x I told you about, and substitute it, and you get -2. So, -1, -2. And then take the other x value, which is -4, substitute it in. And then 1, so the point is -4, 1. And then you say, I'm done. I'm like, well, sort of, except nobody knows where your answers are. So, write them together. So they belong together. There you go. -1, -2, and -4, 1. Good times. Nothing terribly hard here. Just, hey, try throwing these things together using skills you probably already have. So that's it. Thank you very much for watching, and have a good day. Let me know if you have any questions.